Welcome to Spring LIB.
So in this problem, we're going to be using the concept of circular motion, so I'm going to review it. So consider that we have a particle that's undergoing circular motion. We can decompose the acceleration of this particle into two components. One of them is a centripetal component, and another one is the tangential component. The centripetal component points towards the center of the trajectory and is equal in magnitude to v squared divided by r, where r is the radius of the trajectory. The tangential acceleration, on the other hand, is equal to the derivative of the speed with respect to t and accounts for the change in speed, while the centripetal acceleration only accounts for the change in direction of the velocity. Okay, so this is what we need in order to solve the exercise. So what we have is a ball that's attached to a cord that has a length L. The ball has a mass m, and the configuration of the system is as shown here in the picture. So we have the ball attached to the cord. The cord is making an angle of theta with the vertical, and a certain velocity of v0 is given to the ball that starts rotating around the center. And our goal is to find, actually our goal is to prove that this relation is true. So we have that the tangent of theta times the sine of theta is equal to v squared divided by gl. Actually, v0 squared divided by gl. Okay, so in order to do that, what I'm going to do is to draw a free body diagram on our ball. So consider that this here is the ball, and this is the cord. Makes an angle theta with the vertical, I'm sorry. And the forces that act on the ball are the tension that acts in the direction of the cord, and also the gravitational force that points downwards. Okay. And I'm going to decompose these forces into two components. So we have the y component and the x component. So in the y component, notice that the ball doesn't move in the y direction, so the sum of the forces must be 0. So we have t times cosine of theta minus mg is equal to 0, while for the x coordinate, we only have t times sine of theta, and this is equal to the mass times the centripetal acceleration, and that's v squared divided by r, as I said before. Okay. Now from the first equation, we have that t times cosine of theta is equal to mg. And from the second equation, I'm just going to copy it here, t sine of theta is equal to m v squared over r. So I'm going to take the second equation and divide it by the first one. So if we do that, what we obtain is, we obtain that sine of theta divided by cosine of theta, that's tangent of theta, is equal to v0 squared divided by rg. Now, what is r? Notice that the length, this here is the length of the cord, and the radius of the trajectory is this thing here. So we have that r is equal to L times the sine of theta. So I'm going to substitute it in the equation that we had. So we have tangent of theta is v0 squared divided by r, and that's, as I said, L sine theta times g, and I'm going to multiply both sides by sine theta. So we have tangent of theta times sine theta is v squared divided by lg. And this is exactly what we wanted to find, which concludes our exercise.